All right, so Eric, Nathan, are you on page 1?
I'm just finding my book.
Okay. So this topic is called the real numbers. Okay, so basically it talks about all kinds of different names, different groups of numbers. Okay, so part A is talking about definition. Okay, give you a definition of what kind of numbers are called integers, what are called whole number, and so on. And then after that, we put them all together into a tree, right? So this is called a real number system. So you need to be able to identify when you see a number, whether it's irrational or rational, right? Whether it's a whole number, which group it belongs to, okay? So let's start with the definition. So integers, everybody already know, okay? So integers includes the positive numbers, negative numbers without decimals, and also includes the zero in the middle, right? So look at the yellow highlighted. These are examples. Whole numbers, it starts from 0 and then 1, 2, 3, okay? So ignore all the negative, okay? 0 and then 1, 2, 3, and so on. Natural number, it does not include the 0, okay? So it starts from 1, 2, 3. So the part that's easy to mix up is the whole number and natural number, right? Which one includes 0, which one doesn't? So the way I remember two different ways, okay? Natural number, you can think of it as the natural way to count things, right? To count objects. For example, I will be counting how many students there are in the class. So I will count 1, 2, 3, 4, 5, 6, 7. Okay, there are 7 students in this class, right? So I won't be starting by counting, okay, 0 student, 1 student, right? That doesn't make sense. If 0, I don't need to count. It's not even there. So naturally, if you want to count, it's always 1, 2, 3, 4. Okay, so that's one way to remember that. Or you can just use the word whole number. Whole number has the letter O. Okay, I'm using the red. O looks like a number 0, right? So it has a 0. Okay, so it has a whole, so you start from 0. Look at natural. Natural, it doesn't have the O, right? So it doesn't have the 0. Just a little trick, okay? So you won't forget. And then prime number. Prime number is the thing that we want to focus on on this page, okay? So prime numbers are natural numbers that has only 2 factors. Does anyone know which 2? Colin?
One in itself.
Yeah, very good. Okay, has only 2 factors, 1 and itself. So for example, Yosher, what will be a natural, prime number?
3.
3, because?
It only has 2 factors,
Okay, so which 2?
1 and 3.
Yeah, very good. Okay, so for example, prime numbers, put it in here, prime number will be like 3 because it's 1 times 3, right? Or same as 3 times 1. So we know it will be a prime numbers, okay? And composite number is anything that is not a prime, right? So you will check if it's a prime or not. If it's not prime, it must be composite. So that means it's made up by more than one in itself, okay? There are more combinations, okay? So let's say we try another prime. Nathan, can you give me a prime?
5.
5, because?
It's just 1 times 5 or 5 times 1.
Yeah, very good. Okay, simple enough. And Eric, can you give us a composite?
4.
4, because?
It has more than one factor or 2 factors.
Yeah, for example?
1, 4, 2.
Yeah, okay. 1 times 4 or 2 times 2, right? So it has more than, it's made up by more than one combination, right? Instead of just 1 and 4, it can made up by 2 and 2, okay? Another example would be like 10, right? 10 can be 1 times 10, 2 times 5, right? And that's all, right? 1 times 10, 2 times 5. So these are composite numbers. Now we have also a couple terms we need to go over. One thing is called a factor. So these are called factors. Okay, let me write it here. Okay, so factors and multiple. Okay, so for example, let's say we have, we'll use 10 again, right? So 10 is 2 times 5. So these numbers here are called factors. And the 10 will be called a multiple. Okay, so we will say 10 is the multiple of 2, right? 10 is multiple of 5. And then I can say 2 is the factor of 10. 5 is the factor of 10. Okay? So 10 is also a factor of 10 as well, right? Because 10 can become 1 times 10, right? So 1 and itself are also called factors. Right, so please write these down, okay, on your notes. And once you finish copying, can you raise your hand? Oops. So prime, composite, factors, multiple. Okay, so you need to get these terms remembered. So later when we mention it, you know what we are talking about. Right, so please raise your hand when you finish writing all the notes down. Okay, so when the number is small, like 3, like 5, we can tell whether it's a prime or not, right? Very easily, we can just see it, right? Because it's in the times table. But when the number gets bigger, like 239, right? 567, how do we know if it's a prime or not, right? So there's a prime testing rule. So we'll go over where that rule come from, and then we can use it to check like 2047, right? Something like that. Is that a composite or prime? Okay. With something that we know, right? We'll start with something that we know, something smaller first. We'll do 100. So 100 for sure is not a prime, right? It can be made up by many things, okay? So we'll start from small numbers, okay? We'll write out all the pairs of factors, okay? So let's say we do 1 times 10, right? 1 times 10. Please don't write too big, okay? Because there are many pairs. And then we can do 2 times 50, right? So we already know it's not a prime. So what will be the next factor coming up? Aaron?
4.
4, very good. 4 times what?
25.
25, okay. And carry on. Well, what is the next one, Brennan?
5
Yeah,
times
5
5.
times.
But more importantly, is the first one's supposed to be 10 times 10, not or 1 times 100.
Oh, 1 times, yeah, sorry. Yes, 1 times
100.
100, yes. 5 times, yeah, Brennan, 5 times.
20, sorry, 20.
Okay.
20.
Yeah, thank you for picking that up. That's a good call. Okay, 1 times 100. Okay,
Hey,
one.
Sam.
Yeah?
Is there also 10 times 10?
Yeah, also 10 times 10. So that's after the 5, right? We're going in order. So 10 times 10. Okay. Did we miss anything? 1, 2, 4, 5, 6, 7, 8, 9 don't work, right? Okay. So, and then 10 after 10. What will be the one after 10? We have 1, 2, 4, 5, 10. Is there anything that will work after 10? Eric?
I don't think so.
No more? We can do 20, right?
Oh, I thought it would just go back.
Okay, so 20, yeah, so it will, like you said, it will go backwards, right? So it'll be 20 times 5, right? Sort of reverse around. And then 25 times 4, okay? So that's why I asked you to write smaller so we can fit all in. And then 50, right, times 2. And then 100 times 1. Okay, so what's the point of writing it reversed, right? Because they're basically the same thing. So the point is we can see that after it reaches 10 times 10, it's kind of like the middle, right? And then after the 10 times 10, everything is the same as before. So if we want to check if it's prime or not, we only need to check everything before the middle part. And the 10, right? Because it's 10 times 10. So the middle part came from square root of 100, right? It sort of cut the 100 in half into two factors that are the same. So you just need to check all the prime numbers that is before the square root of 100, right? So for example, you will check 1, right? 1 times 100, that's a factor. And then you check 2. 2, it works, right? 2 times 50, then you know already it's not a prime, okay? If 2 still doesn't work, you keep on checking. You don't need to check 4, because 4 is not a prime. You check 5, okay? So if 5 is not a factor, then you know the number you are checking is not a prime. Okay, so you check everything before the square root of the number you want to check. Okay, you check all the prime that is smaller than the square root. So we'll try an example. Okay, so for example, I want to check 239. So of course I know it will start with 1 times 239, right? But I want to see if there's other pair that could work. But then in the middle, I know everything after the square root of 239 will be the same as the ones before, right? Because somewhere in the middle, right? Two numbers. So, okay, let me not write the square root 239. So we just we'll find the square root of 239. So everyone, please take out your calculator and calculate square root of 239, okay? And raise your hand once you got the number. All right, Yosher, what's your answer?
15.5.
Yeah, 15.5, okay? So we know if we square root the 239, it will be about 15.5 times 15.5. And everything after 15.5, the factors will all be reversed, right? So all I need to do is to see if I can find any factors before 15.5, right? So all the prime, we just need to check all the prime before 15. So we can check 2, right? 2 is a prime. 3 is a prime. The prime next one will be 5, 7. What's after that? What's the prime after 7? Brennan? What other prime after 7?
11.
11? Okay, so we need to check 11. Okay, so we have that. And then we have 13, right? 12 is not a prime, we check 13. So you just need to divide each one. See if any of those can be divisible, right? If any of those are factors of 239. Okay, so you guys can start checking, right? You take 239 divided by 2, see if it has no more decimals, right? See if it's a factors. All right, can you raise your hand once you finish checking? So you divide by 2, divide by 3, divide by 5, 7, 11, 13. Okay, does any one of them a factor of 239? Okay, and Colin, does 2 work?
None of them work.
Okay, okay, so you give us all the conclusion. So 3 doesn't work, 5 doesn't work, 7 doesn't work, right? If none of them works, that means 239 is a prime or not, Sarah? Is 239 a prime? Sorry, I cannot hear you, Sarah. Is your mic working? Still can hear. It's okay. I still can hear you, but maybe later, okay? Nathan, you checked, right? None of them works. So
Yeah,
if,
none of them work.
yeah, so 239, is it a prime?
Yes.
Yeah, okay. So this one, it's a prime. Okay, so you understand the idea here? We don't need to check every single number, right? You don't need to check from 1 to 239. You just need to check all the prime before the square root. Okay, so if you look at the rule now, prime testing rule, we test all the prime such that it's smaller or equal to the square root of the p. P is the number you want to test. Okay, smaller means less, right? Smaller or equal. So let's try 5, 6, 7. So we can start with 1 times 5, 6, 7, right? And then we need to find the square root of 5, 6, 7. All right, Colin, what is square root of 5, 6, 7?
23.8.
Okay, so we'll be checking all the prime before 23.8. So that includes 23, right? 23, I think, is a prime. Okay, so you need to list out all the prime up to 23. You can go from small to big, and then once you found any one that works, then you can already conclude it's not a prime, okay? You keep testing until you reach 23 if you need to, right? Right, so please raise your hand again when you finish testing. Okay, Brandon, Eric, Nathan, are you done?
Almost.
Okay. Right, so I'm going to just go over one by one, okay? And you tell me if it works or not, all right? So 2, okay? Does 2 work, Aaron?
No.
Okay. And then next one will be 3. Does 3 work, Yosher?
Yes.
Oh, already? Okay, 3 times what?
189.
189, okay, so 189. So right away, we can already conclude, right? Because we found a pair that's other than 1 and itself. 3 times 189, then it's not a prime, okay? So it will be a composite. Okay, let's finish up the list, okay? See if we can find any more, okay? After that, 5 doesn't work, right? Because for 5 to work, it has to be ending with a 5 or 0, okay? So let's check the next one. 7, does 7 work, Colin?
Yeah. It's
Okay. 7 times
81.
81, okay? All right, so there you go. There's another pair that could work. So it's definitely not a prime. Okay, after that will be 11. Okay, does 11 work, Nathan?
Let me check. No, it does not work.
Okay, so 11 doesn't work. And then after that will be 13. 13, does 13 work, Brendan?
Nope, doesn't work.
Okay, and then we have 17. Eric, does 17 work?
It doesn't.
Doesn't, okay. 17 also doesn't work. 17, and then we have 19, right? 19, Aaron, how about 19?
No.
Okay, 19.
It doesn't work.
Yeah, 19 doesn't work. And then 21, 22, 23. Last one, Yosher, how about 23?
No.
Okay, so the only pairs that works will be 3 times 189 and 7 times 81. Okay, but all you need is just find one pair other than 1 in itself. Okay, then you know it's not a prime. Okay. So let's finish the testing at the bottom here, and then we'll have a break, okay? So I'll let you try. This part is not just testing prime or not, you need to list, okay? Please list all the numbers C. What does that mean? Number C is the number here, okay? C is the number that you use to test. That's the number C. So you can write down, right? So for example, like for 567, C will equal to 1, 2, 3, 5, 7, 11, okay, and so on. After you list out all the C, then you do the checking, okay? And then you check. So your conclusion is prime or not prime. Right, so pretty straightforward, right? So list out all the C and then test for prime or not. So when you finish, please raise your hand, okay? Question D is up to the 2047, right? So it's a challenging one, has quite a lot to test, but you got a calculator, okay? Should be manageable. If anyone has questions about what to do, let me know. So I'm writing out just 1, 2, 3, 5, 7, and then I will get the rest of the C from you guys. right, let's start with the square root of each number first. Okay, Aaron, what's the square root of 437?
20.
20.9.
9.
Okay, thank you. And Brennan, for question B, what's the square root of 521?
22.8.
Okay, 22.8. And Colin, next one.
18.5.
Yeah. Eric, last one.
45.2.
Okay. Right, so you will need to list out all these C up to the root, okay? So first one, 1, 2, 3, 5, 7. So next one can be 11, 13, right? And then what's next one? 17, 19, right? That's all, right? Up to 20. 20 is not a prime. And then you test each one of them. Once after you do the testing, write a conclusion, whether it's a prime or you can say it's a composite, okay? Or you can say it's not a prime. All right, please raise your hand when you finish all the testing. All right, let's go over question A first. Yosher, for question A, how's the test?
It's composite
Because,
because it's divisible by 19.
yeah, okay, so 19 will work, 1 will work, everything else failed. Okay, so it will be 19 times what?
23.
Okay, so therefore it's a composite. Okay, next one, Colin, what did you find?
It's prime.
Fine, okay, so everything failed.
Yeah.
Well, except one, right? So only one works, so it's a prime. So 5, 2, 1 can only be 1 times 5, 2, 1. All right, Eric, are you done?
Almost.
Okay, on the last one?
Yeah.
Okay. Right, so for C, the prime number that's up to 18 will be 11 and 13 and 17, right? So not too many. Okay, Nathan, what did you find for C? How's the test?
I got 7 times 49.
Okay, so 3, 4, 3 can be 7 times 49. So what's your conclusion?
It's composite.
Yep, composite. Okay, Eric, are you done now? I'll let you handle the monster one.
Yeah, I'm just checking the last few.
Okay. So we have quite a lot to check, right? 11, 13, 17, 19.
I think it's not because I only found 23 and 89,
So
but that's another one besides 1 and 2047.
23. What's the prime after 23?
29.
You skip one, skip two. After 23, there's more prime.
Isn't it just 29?
23, and then we have 29. Sure, yeah, 29 and what else? What's after that?
31.
31. Go on.
Let me check my notes. So there's 37
Mm-hmm.
and then 41,
Yeah, 41,
43,
43.
47.
We don't need to do 47, right?
Oh yeah, it's only up to 45.
Yeah, okay, so did you find anything that works?
I did 23 and 89.
Okay, so that means, what does that mean?
It's a composite.
Yeah, okay, so times 49. So composite. Okay, so that's how you check if it's a prime or not, right? So let's have a break right now, and then we'll continue. We'll just do 10 minutes, okay? So 11:22. Okay, so we'll continue at 11:22.